So we're going to start today with learning the names of parts of right triangles. So when we're talking about a right triangle, it's important to note that somewhere in that triangle, one of the three angles, specifically this one right here, is going to be a right angle, which has a measure of exactly 90 degrees. The two sides of that triangle that form that right angle excuse me, are called legs. Okay, this is a leg and this is a leg. You have two legs. A right triangle also has two legs. Now the legs are the shorter sides. Then we have this side that is across the triangle from the right angle, and it is the longest side. That's fun. And it has a fun name. It's called a hypotenuse. With that, we're going to switch over to this page. And you will find these in your OneNote. All right, so looking at this, what are the lengths of the legs of the right triangle? Looking at this first question. So the legs are the ones that form the right angle. So the length of one leg is 3. The length of the other leg is 4. And then the length of the hypotenuse. That one is the one that's across the triangle from the right angle, and it's the length of 5. What are the areas of the squares off of the legs? So the area of this square right here. So we count the little dooflachis inside. Or if you know the square is 3 squared for the area, so 3 squared is 9. Either way you do it, you're going to get 9. Looking at the other leg and the square that's off the side of it, we could count all these squares here, or we could say 4 squared is 16. Then it says, what is the sum of these two squares? These two areas. So this is 9 and 16 together. It's 25. Next question says, what is the area of the square off of the hypotenuse? So taking this guy, and if I count all the squares, or if I said 5 times 5 for the area of this square, it would be 25. Explain the relationship between the sum of the areas off of the legs and the area off of the hypotenuse. So I'm not sure if you've noticed, I hope you have. Look right here. When we put these two areas together, it's the same as the area of the hypotenuse. Do you think all right triangles will have lengths that are integers? Explain. Okay, so you got to think about, what does an integer mean? What is an integer? It's all the whole numbers and their opposites. Will right triangles have lengths that are integers? So what do you think about that? All right, so there we go. All right, so looking at the second one. What are the lengths of the legs of the triangle? So one leg is 6. The other leg is 8. What is the length of the hypotenuse? 10. Remember, I know it's this one. One reason is I know because it's the side that's across from the right angle. The other reason I know that it's the hypotenuse is because it's the longest side. 10 is longer than 6 or 8. All right, what are the areas of the squares off of the legs? So for 6, for this leg, the area of this right here, of this square. So again, if you wanted to count, you could count them all. So if you need to count, then pause the video and count them all. Or you could also do 6 times 6 for the area of this square, and that would be 36. This one would be one where I would not want to count. 8 and 8 are the lengths of the sides of the square, so 8 times 8 is 64 for this area. What are the sum of those two areas? So if I take 36 and I add 64, I get a total of 100. What is the area of the square off of the hypotenuse? So I'm looking at this hypotenuse and the area of this square right here. And this one's nice because it's a 10. So there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So the area of this square is 100. Look at that. What do you see here? How did we get this 100 right here? What did we do there? What is the relationship between the sum of the areas off the legs and the area of the off the hypotenuse? So let's zoom in on this real quick. I'm going to focus on this part. So theoretically, I could take this square and this square and fit it in this other square. So what I'm going to do is I'm going to color an 8 by 8 inside here. So there's 8, and there's 8. So this is an 8 by 8, and this is an area of 64. So then I'm going to count all these other squares that are left and see what's left. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, which is the area of this square right here. This area was 36. This area was 64. Do you think that will hold true for the previous one? So let's go back up and check that one out. Erase this. Okay, so I'll take the area of the largest square right here from the legs and make a 4 by 4 this way. So there's 4 by 4. And that's an area of 16 right here. Then I'm going to count all these other squares that are left and see what I have left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at that. So if we could decompose these areas of these two squares, we can fit them perfectly inside this other square. So let's go take a look at the third one. What are the lengths of the legs of the right triangle? All right, lengths of the legs. That's a 5. And the other leg is a 12. What is the length of the hypotenuse? It's that one, the longest side, 13. It is also the side that is across from the right angle. What are the areas of the squares off of the legs? So this shortest leg, what's the area of this square? What's 5 squared? 25. Now, what is the area of this square? What is 12 squared? Let's pretend my pen will write 144. What is the sum of those two squares? 25 plus 144 is 169. What is the area of the square off of the hypotenuse? So this is 13 and this is 13, and 13 times 13 for the area of this square is also 169. Explain the relationship between the sum of the areas off of the legs and the area off of the hypotenuse. So what is the relationship between this and this? The sum of the two areas from the legs is equal to the area off of the hypotenuse. Okay. So looking at this one, what are the lengths of the shorter sides of the triangle? The two shorter sides are 5 and then the other one 7. We got 7 here and 5 here. What is the longest side? 10. What are the areas of the squares off of the shorter side? So the area of this one would be 25. And the area from this one would be 49. What is the sum of those two areas? So we're going to take 25 and 49. Here we go. Better. What is the area off the square, off the longest side? Well, 10 squared. 10 times 10 is 100. It's not 74. What is the relationship between the sum of the areas off the shorter sides and the area off of the long side? There isn't a relationship. If there is no relationship, why do you think so? What's the difference between this triangle? How is this triangle different from the 3 previous triangles that we were looking at? So, what do you think about that? Right triangle, then you'd be correct. So now that we've discovered this, we're going to go back and take a look at this. What you have just discovered is the Pythagorean Theorem. And the Pythagorean Theorem states that a squared plus b squared equals c squared for every right triangle. Okay, now what's A, what's B, and what's C? Right, A and B are going to be your legs. C is going to be your hypotenuse, always. C is always the hypotenuse, C is always the longest side. If it's not, something is not right. So, but it's not just A plus B equals C. That's not what it says. It's saying the area that comes off of A, the area of the square that comes off of A, together, added to the area that is off of leg B. When you add those two areas together from those legs, you will get the area off of the hypotenuse of that square. So a squared plus b squared equals c squared. That's your Pythagorean theorem. And that's all we have for today. Thanks for listening.